If you live in a place with a really shitty weather, such as Quebec, Canada, just like me, you might have noticed while checking the weather forecast that during the summer, as if the weather was not hot enough, it says that you're gonna feel it even hotter, and usually says that it's because of the humidity, and they call it a humidity index, humidex, or even heat index in some places. Likewise, during the winter, it usually says that even though the temperature is really cold, you're actually gonna feel it even colder, and usually the explanation for this is the wind, and this phenomenon is called wind chill. So in this video, I just want to explain those two phenomenons. To explain them properly, I'll have to introduce a few subjects first. The first one is that I wanted you to be aware of how the human body perceives temperature. It's important to know that our bodies don't actually sense temperature, but actually what they do is that they sense the rate at which you acquire or you lose heat. And this is why, for instance, if you're in a room that is, let's say, at 20 degrees Celsius, and you touch a metal object in that room, that metal object will feel usually colder, even though both the room and the metal object are at the same temperature. The heat still transfers better through the metal than through the air, and thus you will feel as if the metal was way colder. The same happens when you go to a pool at 20 degrees Celsius. You will feel it pretty cold, whereas when the temperature outside is 20 degrees, you will feel it's pretty warm. Then again, the reason is because in the water, the heat will be transferred easier than through the air. And now I just want to talk about heat transfer really quickly. There's three mechanisms that are known for heat transfer. They are convection, radiation, and conduction. Conduction and radiation won't really be important for this video, but I'll still talk about them briefly. Conduction is essentially the transfer of heat through neighboring particles, which is the reason why this happens in solids. It's because of the kinetic energy that the particles have in the solid. What will happen is that there will be microscopic collisions between the atoms and the electrons that compose the solid material, and thus the energy will propagate. Because electrons are also involved in this process, usually materials that are good electrical conductors are also good thermal conductors. Not always, but in most of the cases that's how it works. Then radiation is the transfer of heat through electromagnetic waves. Usually this happens, actually that electromagnetic wave is released by an electron going from a higher energy state to a lower one. And this kind of heat transfer is, for instance, the one that makes the sun heat the earth and other planets. Actually, all bodies that have a certain temperature will emit that radiation. But I think the sun is like the best example I can give for this. And finally, convection. Convection is a bit more complicated than the two others, at least I find. And essentially, it's similar to conduction, in which it's a particle that transfers its kinetic energy to another particle. However, convection doesn't happen in solids, but instead in fluids. And in fluids, usually the particles have more freedom of movement. And in case of gases, well, the particles are far apart, so it's not like they are neighboring to each other. So what happens in convection is that essentially the particles, instead of transferring their kinetic energy to another particle just through a microscopic collision, the particle actually travels a certain distance and then through a collision transfers the kinetic energy. For instance, this is how the heat is transferred in the air, which is how the heat is transferred when you're walking outside, essentially. And also another thing that is important to know for the three types of heat transfer is that it's always the warmer body that transfers the energy to the colder body. This is because of the second law of thermodynamics. There's no really an explanation for it, it's just how it seems to be. And lastly, something important to consider is that the two elements that will determine how fast the heat transfer rate is, will be the heat transfer coefficient. The higher it is, the faster the transfer will be, and the temperature gradient. The temperature gradient is essentially the difference of temperature between the two bodies exchanging heat. So the bigger the difference, the faster the heat will be transferred. The smaller it is, well, then less transfer there will be. If two bodies are at the same temperature, then there will be no transfer at all. So as I said, when we lose heat through the air, so essentially when we lose heat and give it to the atmosphere, the mechanism of heat transfer that is going on is, well, it's both radiation and convection, but we will focus on convection for this because I want to explain how the wind has an impact on it. Essentially, the heat transfer coefficient for convection is increased when there is agitation in the particles that transfer the heat. And in the case of air, well, what will increase that agitation will be wind. So when there's wind, the transfer coefficient increases, and thus the heat transfer rate increases as well. That is interpreted by your body as if the temperature was lower. This is why when you will see in the weather forecast that the temperature is 0 but it feels like -10, it means because of the wind you're having that day, you will be losing heat at the same rate as if it was -10 degrees Celsius, but there was no wind at all. If the wind speed were to increase, then you would feel it as even colder. So you would say instead it feels like -15 or something like that. And if the wind was way weaker, then it would probably feel like -2 or -5 or something like that. And naturally, if there's no wind, well, then it will just feel like -0. Sorry, 0. I was just confused, but you get the idea. Okay, finally about humidity index. So before I talk about this subject, I have to introduce two other principles. The first of them all is something that we have to consider when we think about our body temperature. Essentially, the body has to kind of manage our production of heat according to how much it's losing. The problem is that our bodies have to keep a constant temperature inside, usually between 36 or 37 degrees Celsius. Going to a few degrees above that or below that can be very dangerous. The problem is that since we are living creatures, the chemical reactions inside our body produce the waste heat, which heat up our body. Since there is a constant production of heat inside our body, but we also need to keep a constant temperature, our bodies need to have a way to lose that heat. And usually that's not a problem because the temperature outside usually is lower than the one of our body, so we just cool off, Sometimes, however, of course, it might happen that the temperature outside might be too low, and in that case we lose more energy than the one we can produce, and that's when you get very cold, and that's when you need to wear clothes to increase the isolation between your body and the atmosphere. But when it's hot, the problem is that it may happen that the rate at which you lose heat to the atmosphere might be not enough and actually lower than the energy you produce, and that will raise the temperature of your body, then that's quite dangerous. To make it even worse, it might happen that the temperature outside might be the same as the one in your body or even higher, and in that case, well, you will not be able to lose energy through the atmosphere by convection, or even worse, you might actually be gaining energy through the air. The good thing is that for that kind of situation, our bodies have a mechanism to lose heat, which is perspiration. I still haven't looked up if it's transpiration or perspiration, but essentially what's happening is that the moisture in our bodies will usually evaporate because usually our bodies are more humid than the atmosphere. And perspiration, essentially what it does is that just makes that evaporation easier by exposing the water in our body to the atmosphere so it can evaporate easier. This that evaporation of that water cools us because water requires a lot of energy to go from its liquid phase to its gas phase. Since it requires a lot of energy, we'll be able to absorb a lot of heat when it evaporates, and essentially when it dries, So that way you can keep yourself cool even if the temperature outside is very high. However, just like there is heat transfer, there is also mass transfer, and the loss of heat through evaporation is a case of what is called heat transfer induced by mass transfer. And in mass transfer, in the case of the evaporation from our body, is essentially a very similar mechanism to convection, the convection that I explained for energy. But in this case, it's convection for mass transfer. And just like heat transfer through convection involves heat transfer coefficient and a temperature gradient. Well, mass transfer, the mass transfer, sorry, involves mass transfer coefficient and concentration gradient. The concentration gradient is essentially the difference of concentration between the two bodies exchanging mass. In the case of the evaporation of the humidity in our body, it will be the difference between the humidity in our bodies and the humidity in the atmosphere. As I said, usually our bodies are more humid than the atmosphere. However, that's not always the case. Sometimes the atmosphere might be, well, I mean, actually yes, actually most of the time it is less humid than our bodies, but the problem is that sometimes the humidity might be very high and thus near to the humidity of our bodies. And then again, as I said, if the concentration gradient is low, then the mass transfer rate will be low. And since that mass transfer induces heat transfer, then the heat loss will be low as well. And thus our bodies will start accumulating heat from the production of heat that comes from our metabolism. The worst case you can have with humidity would be if it's so humid outside that the relative humidity has reached 100%. When that happens, essentially it means that the atmosphere has reached the saturation pressure of water at that temperature. And if you know what the saturation pressure is, you would know that it means that there cannot be any more molecules of water in the atmosphere, because if that happens, that would technically raise the pressure above the saturation pressure, which will just not happen. So, as I said, if the saturation pressure has been reached, there cannot be any more water molecules that go into the atmosphere. So it means that the humidity in your body will not evaporate. You might sweat, of course, and you will just be wet, but that water is not going anywhere. So you will essentially lose your heat loss mechanism through evaporation. And that's a really important heat loss mechanism, by the way, because as I mentioned previously, water can absorb a lot of energy when it evaporates. So for that reason, when the humidity is really high, well, you will just feel as if it was even warmer, because that low heat transfer, your body will be interpreting it as a very high temperature. Or even worse, if you are just accumulating heat because the heat transfer is extremely low and you are actually producing much more heat than what you are losing, then your body will see it as an even bigger temperature. If in any situation you find yourself in a situation where the temperature is higher than the one of your body and the humidity is higher than the one of your body, that's usually a really dangerous place, and you should try to minimize the time you spend in that place, and if possible just avoid it. The consequences can get very severe in really short amount of time, because you will accumulate heat very quickly, and as I mentioned, your body will not be able to withstand a temperature of just a few degrees above the normal temperature without having severe consequences. So that pretty much wraps it up. That's pretty much it. Of course, there is other subtleties to be considered, but those are quite minor. I just want to explain really the main, the way simplest and most important elements that decide wind chill and humidity index. So I hope you learned something in this video, and if you did, well, just like the video, and thank you, and have a good day.